Now that you have theoretical knowledge of how to parallel the eForce batteries with Envy True12 inverter or Envy True12 inverters, I figured it will be beneficial for me to show you what such interconnection would look like in the real world. This is our lab setup. That's why it looks so crude. This is constantly being tested. There's a conduit missing, but for our purposes, this setup is more than enough. You see we have one Envy True12 inverter, we have one eForce unit, 9.6 kilowatt hours, i.e. 2 eForce modules in it. And parallel to all this is one 9.6 kilowatt hour eForce. Let's open the first eWay and let's see what is inside, how such interconnection is established, both in terms of communication cables and power cables. This is what it looks like. Again, this is a lab setup. That's why there are cables that are too long, there are cables that are extra, but in any case, this represents the interconnection well because you see the positive bus bar here and the negative bus bar there. So the positive bus bar, as we've discussed when we were going through the presentation, it has originally 4 different ports. One of them by default is always occupied by the default connector. This one is responsible for connecting the eForces in the stack to the bus bar. So 2 of them are occupied, one by the inverter positive cable and one by the second eForce positive cable. And the same is the case with the negative bus bar. We also see the communication cables being connected here. One cable, namely this one, for communication between the first eWay, the one that we're looking at right now, and the Envy True12 inverter, the single inverter in this particular system. There's one cable for optional Guardian to communicate with the first eWay. Having optional Guardian allows you to participate in VPP programs. It also allows for you to see more battery specific data in more detail. And also, if it ever comes to that, the troubleshooting when the Guardian is in place is easier because more data is available, and actually some firmware updates and so forth can be done without actually connecting a computer to the battery units. So this is what the first eWay looks like. And now let's take a look at the second eWay. This one's on me, the lock is fine. So here, because this particular eWay does not directly connect to the inverter, you have one port available and then the second port available as well. So there's only one positive cable connecting this battery to the first eWay, and there's also one more negative, obviously, to have a complete circuit. And you see that there's a communication cable going from this eWay, or this stack of eForce, to the first one. I know that during the theoretical portion of the training, I mentioned that the Guardian is only supposed to be in the primary eWay, the first one, but in this case, because this is a lab setup, we monitor 2 different Guardians and we monitor their performance with 2 separate eForce units. So yeah, this is what it really looks like, and obviously, needless to say, in the inverter, there are only 2 ports occupied by the battery power cables, one positive and one negative, so we can take a look at that right now. And voila, you see only one positive and one negative being connected there, which means that the other positive port and the other negative port are fully vacant. Now that you have fully visualized how connections are made between the eForce units and the Envy inverter, solely using the bus bars that are included with the equipment, I truly hope that this knowledge will make it easier for you to design the projects and manage the space that you're given to work with, and also to manage the cables better to maybe save $1 or $2 here and there. Thank you very much. See you next time.